Okay, so this is a system of equations question. It's always the last question on the Algebra 1 Regents, and it's a 6-point question. So more or less, the way that this is kind of broken down is you pretty much get, 2 points for writing out your system. You get another 2 points for whatever the second question is, and like another 2 points for the third question. Okay, it can vary slightly from year to year. Okay, but that's pretty much the breakdown for the most part. Okay. So first off is reading the question and understanding what they're asking. So it tells me here, Jim had a bag of coins, the number of nickels, N, okay, that seems important, and the number of quarters, Q, okay, totals 28 coins, right? So he's got 28 coins. Some of them are nickels, some of them are quarters. Now, I know together the combined value of the coins is $4. Now, my first goal is to write a system of equations that models the situation. Now, there's different ways that these systems of equations questions typically show up, right? And my main goal at the end of the day, though, is to write two different equations. Okay. So the problem that a lot of students have sometimes is thinking, okay, it's like I've only got a 4 here. I've really only got two numbers in this situation here. So how can I take just those two numbers and use them to write out two different systems, right? Now, the first one, okay, is kind of have to do with the total number of things that he has. So what I note here from this very first sentence, okay, is that he had N nickels and he has Q quarters, and all together, he's got 28 coins. So this here is going to tell me the relationship between the number of nickels and the number of quarters together gives me 28, right? For example, if he had 10 nickels, he'd have 18 quarters and so on. If I know one of these, I can figure the other one out. But as I change these, that's going to change how much money he has, right? If he has 0 nickels and 28 quarters, that's a lot more money than if he had, say, 28 nickels and 0 quarters. So how do we actually narrow down how much he has is we have to use this second piece of information here, okay? Is it tells me how much those coins are worth. So altogether, I know what that total is, okay? But the question here, really the part that students struggle with is it's almost like they left something out because they are making an assumption that we know what a nickel is worth and what a quarter is worth. Okay. That's the information that I need to finish off this second equation. Is I know that a nickel is worth 5 cents and a quarter is worth 25 cents. Okay. Once I have those two pieces of information, I can fill out the second equation here. So if he had N nickels, it's going to be 0.05 times N. And if he has Q quarters, it's 0.25 times Q. Okay. So this here is my system of equations. Okay. The number of nickels plus the number of quarters is equal to 28. And 5 cents times the number of nickels plus 25 cents times the number of quarters is equal to $4. Okay. So that's the first beast I have to struggle with here is just writing that system out. Okay. Now, this here is asking us next for an algebraic solution to figure out here what the actual answer is. Okay, so anytime it says that I'm going to use an algebraic solution, is really I've got two options. Is either I'm going to use substitution or I'm going to use elimination. And at this point, it's really a personal preference to decide which one you'd rather go for. Okay. Personally, I usually err on the side of elimination. Okay. But it really kind of depends on how your system is shown up. Okay. In this specific one, substitution would also work well because I noticed that it'd be easy to solve for one of these variables in terms of the other. Okay. I do prefer to go with the elimination technique because that's usually how you end up solving systems on the last question of the Regents. So I'm going to walk you through that method for this one here. Okay. So I'm going to start off by rewriting my system here. N plus Q equals 28. And my second one here is 0.05n plus 0.25q is equal to 4. Now, my goal here is to get the coefficients of either the x's or, sorry, the n's or the q's to be the same and opposite. Okay. Now, what I realize here is that if I multiply the second equation here by 4 times 0.25, 4 times a quarter is going to give me 1. So that's going to bring this one to a 1. Both of these would be the same. I can then eliminate. Okay. But I actually don't want just the same. I want the same and opposite. So I'm going to use -4 here. Okay. Now, if you need to, just throw this into a calculator. Okay. The problem with elimination sometimes is you end up with decimals. The math sometimes looks a little bit harder, but quantitatively, you're just going to throw those numbers into a calculator. The larger that they get, the more complicated that they look. All right. But I know 4 times 5 is 20. So 4 times 0.05 is going to be 0.2n, but it's negative because I multiply by -4. Okay. Now, -4 times this guy here is going to be minus 1q, which again is what I wanted. Now, on the right-hand side, -4 times +4 is -16. Okay. Again, the main thing to remember is that you're multiplying this by every single term here, okay, including the one on the right-hand side. Now, what I'm going to do is I'm going to essentially is I don't really need this guy anymore. Okay. Is I'm going to take the top equation and add it to the bottom equation here. Okay. What happens here is I've got n minus 0.2n. Okay. So that's going to be 0.8n, positive q, and negative q get eliminated, right? That's what I wanted as I was shooting for that elimination method. Okay. Perfect. On the right-hand side, I've got 28 plus a -16. So that's going to be 4 plus another 8, 12. Now, last step is divide both sides by 0.8. And again, don't be afraid to use your calculator. Okay, as if you have to throw things into your calculator, okay, that's always going to be better than messing up by trying to do it by hand. So I've got 12 divided by 0.8 equals 15. Okay, so n equals 15. And the mistake some students make is stopping right here. Okay, as I'm not done yet, right? Is this here is just the number of nickels. So what do I still need, right? The quarters. At this point, I substitute back into one of my other equations. I know 15 plus q equals 28. At this point, you can probably solve this. You might already visually know what the answer is, okay? But it's important to know our algebraic steps, okay? I subtract 15 from both sides. I'm going to get q is equal to 28 minus 15 is going to give me 13. Okay, so I know now that he has 15 nickels and 13 quarters. Okay, this next question is done. Now, last part. Jim was given an additional $3 that was made up of equal numbers of nickels and quarters. How many of each coin was he given? Right? So for this one here, I do want to first try to figure out how am I going to approach this here? Okay. So now I know that, again, this is going to be kind of similar to the last question there. Okay. Is he's given $3. It was made up of an equal number of nickels and quarters. So I know here that like n is equal to q. And that's really all I know at this point here. Okay, is I don't know the total that he has here, but I do know that if I say similar to what I did for this last one here, 0.05 n plus 0.25 q is equal to now $3, right? But the main thing here that's actually going to simplify this, make it a little bit easier, is I know N and Q are the same. So at this point, I can substitute either of these into here. Either substitute the Q in for here or the N in for here. And I could say 0.05. Let's keep it at Q plus 0.25 Q is equal to 3. 0.05 plus 0.25 is going to be 0.3 Q is equal to 3. Now I'm going to divide both sides by 0.3. Okay. And again, if I'm not sure of the math itself, don't forget, there's no shame in taking your calculator and dumping it into there. Okay, so I've got 3 divided by 0.3. And I can see here, my answer is 10. Okay. So I know here that N is equal to Q is equal to 10. Now, what was the actual question here? It said, how many of each coin was he given? Okay, so he was given 10 of each coin. And my justification is the work that it did to solve it right here, right? Now, this last portion here is a little bit more challenging that you might typically see on the Regents, okay? But again, the way that I solved that was just by using the work similar to what I did earlier, right? It also might be possible in a question like this here, since it's not asking for an algebraic solution, to guess and check and try to figure out some values at work. You eventually could stumble upon the answer, but the algebraic approach works out pretty well, right? But that's everything you need to know.